Hey everyone, this is question 7 in section 11.1 is ANOVA one way, and in this problem we're gonna learn how to do the f-test among 4 groups, 4 means. All right, we're gonna do as well the Levene test of homogeneity of variance, and as well we're gonna figure out whether we need the Tukey procedure or not. All right, and when we can use it or not. Okay, let's get started. This is a company, they want to compare the thickness of toast in 4 different times, and we get the data over here. So this is the number of seconds: 20 seconds, 40 seconds, 60 and 80. And what we're gonna do, we're gonna have to download the data in Excel. It's already done, and there you go, this is our data. All right, so the first question is to figure out what is the f-test and the null hypothesis and the alternative hypothesis. So this is fairly easy question. For the f-test, we have this null hypothesis is always the same. So the mean 1 equals to the mean 2 equals to the mean all the way. So here in this case, we don't have mean 1, we have mean for 20 seconds, and the mean, that means the thickness after 20 seconds of baking, the thickness after 40 seconds of baking, and so forth, right? So we have 4 categories, so we have to stop at 4. So this is the last one, is going to be 4. And the alternative hypothesis is going to be always the same, not all of them are equals, and the C here is going to be 4 as well. So going back to the question, we're going to select 1 through 4. So the A is saying mu1 equals mu2 is going to be all the way to mu4, and not all of them are equals, which is a match for our null hypothesis, and up to 4. You cannot choose B, is pretty similar, but the extension is up to 3 here, so that is not. And obviously the H1 in C and the H1 in D are not the correct one, right? You cannot have mu1 different than mu2 different and so forth. That is not the same hypothesis. So we go with A, right? Let's check it. Okay. So now they are asking for the f-test. So the f-test, it means they want you to run the data analysis on Excel, and then you come up with the F statistic test. All right, so let's get into the steps. So first of all, you need to go to data, and then you're gonna go to data analysis. All right, so here the test that you're gonna select is ANOVA single factor, the first one. You say okay, and you have this ANOVA single factor table, and you have to fill up this table, right? So we start with the input range. You can click on that small icon and you select everything, including the first row, which is the label. Once you select the first row, please select this box, label in the first row, and then the output range where you want to have the results. So we're gonna put it on the same spreadsheet, right? We're gonna select a cell, and we're gonna select it right here next under the table, and say okay. So you get your table, your results, and the value f that you're looking for is this value over here. So that's the f stat. You can change the color, you know, it's better. So you're gonna copy it and then paste it over here, and you need to round to 2 decimal places, so you can delete all the number up to the third one is 4, so it's not going to change the 7, so you're going to be 1.27, and check, it's good. All right, so now it's asking about the p-value. The p-value is the value next to it, so this one over here. Again, you're gonna copy it and paste it, and you want to round it to 3 decimal places, so you're gonna be 0.3469, that will be 347, and check again, we're good. All right, so the conclusion here, so we are making the logic according to the p-value. So here the p-value, I'm going to put the two statement. If the p-value is less than the alpha, you reject 80, and if the p-value is greater than alpha, then do not reject 80. All right, so now this statement, they are exactly the same always. If I reject A0, we have sufficient evidence to reject, and if we do not reject, we have insufficient evidence. So these two statements, they are always the same. All right, so you are about to compare the alpha to the p-value, and our alpha in this exercise is 0.05. you can see it over here, it's given to you, and the p-value is 0.347. obviously the p-value is greater, so we are in the second scenario. All right, we are right here, p-value greater, we do not reject. All right, so do not reject, and we have insufficient evidence, and we check, we're good. Okay, so now what the meaning we do not reject 80? So the meaning of this, that our correct statement was 80 and all the means are equal to each other. So now do you need to do the Q alpha? All right, what is a Q alpha? So Q alpha is a constant that you are supposed to use this table, the standardized range Q, and this you do it only if you want to compare which one of the means is different from the other one. So you want to compare every two means and you want to figure out whether they are different or equals. And in this case we did not reject. Every time you don't reject, you do not do the Tukey procedure. All right, so this is the beginning of the Tukey procedure and we don't really need to do it. All right, so for this scenario, this case, all right, do not do the Tukey procedure. Right, if I am in H1 here, then you need to do it. So if I reject H0 and I have sufficient evidence, then I need to do the Tukey procedure. Okay, so the correct statement therefore here, it is not appropriate to test with toasting time differs in the mean thickness, right? So we're gonna choose B in this case. All right, we don't have to look for the Q. Okay, so here he's asking about the difference of thickness, and again in this case we did not need to do the Tukey procedure, so we don't have any need to figure out who are different. In fact, they are all equals. All right, the test come up, there is no difference between them, so it's not appropriate again. All right, you have to select G to test which one is thicker. All right, so this is the end of the F test. We are proceeding with the second test, which is called the Levene test of homogeneity of variance, right? And let's get back to the section in the book that is talking about this. So this is your hypothesis, you can see it. It's right here, it's pretty similar. So sigma 1 squared equals to sigma 2 squared equals to all the way to sigma n squared. That's depend on sigma c squared. That's H0. And H1, it would be not all the sigma I or j squared are equal. It's pretty similar. All right. And it's the same logic. So here we're going to look for the same thing, which is equivalent to this statement. And remember, the c here is equal to 4. We have only 4 columns, right? So most likely going to be A again, and we check. Do you see here sigma 1 squared equals all the way to sigma 4 squared, and not all the sigma j squared are equal j from 1 to 4. So that's what we need. Okay, we get the null hypothesis. And similarly here is asking about the F test. So the F is another ANOVA test, but you have to make a modification to your table. And if you read your text, here they are giving you the steps, right? So basically this is the test what we're gonna do. Wherever student tip, the Levene test perform one-way ANOVA on absolute difference from the median in each group, all right, not the actual data. So this how we're gonna modify it. So this is the actual data here. So this is the column of the actual data. We're gonna look for the median for each one of them. So the median of this, is gonna be 29.96. We're gonna take 2 away, you see here, and those are the absolute values. So this is the new values for our new table, all right? How we do this in Excel, so let's get into it. First of all, I'm gonna look for the median, and the median is pretty easy. You're gonna be equals, and you're gonna type median. You can see it there. You can use the tab and select the data and enter. And since all the data here, they are in column fashion way and they have exactly the same number of data, you can grab this and drag it from that corner and you get the other means. So those are the means of different groups. Now what I'm going to do, I'm going to start another table. So I'm going to copy the labels, and I'm going to start under the first one, equal sign. I'm going to use the absolute value, so ABS, open the parentheses, and then I'm going to click on the first value on the table minus the median, which is on below here, and close the parentheses. That's the first one. So here I'm going to go back and fix it. So the reason I'm going to go back, because I'm going to drag it down later on. However, if I drag it on the side, I'm going to get the remaining values. So for example, this is 0. If you double click it, is absolute value of 0.9 minus 0.9. So the 0.9 is the first value on the fourth column, and the 0.9, the red one, is the median of the fourth column. Okay, so once we get this, we're gonna go one by one, and I'm gonna go to the second term and I need to lock it. So lock it, whenever I drag it down, that term is gonna be fixed. Only the blue term, it would be translated down. So how can I lock it? The easiest way is to use F4 on your keyboard. It could be different for different computers. If you are using a Mac, I'm using Windows here. So enter. After I lock it, I'm gonna drag it down 3 units because there are 3 data here, and you can click on one of them, for example, and you see here that the absolute value of this minus the red, all right, and that's what I want. So for the one previous to it is this 0.5 minus 0.6, and again that's what I want. Okay, so we know how to do this. Another way to do it, you can go to before the letter and you type in a $sign. So for me it's Shift and 4, and before the number, and you can type in a $sign as well. So that's again, you can lock it. All right, so either F4 automatically, or you can type in the $signs and drag it down. And again, double click on one of the cells to double check, and that's correct. That's the third cell here minus the median. All right, let me proceed with the remaining ones. Okay, all set. So this is my new table. So the Levene test of homogeneity, I'm gonna do the ANOVA test for this new table, right? So these values here, and let me put it in the table. There you go. All right, so let's go to data analysis, and ANOVA single factor again. And I'm going to select the data right now here. Click on this small icon and select all the data, including the labels. Make sure the labels you checked. 005, that's our alpha actually. And the output, I'm going to put it on the same spreadsheet. I'm going to click on this box and put it somewhere again under the same table. All right, so let's say okay. So this is my test. All right, and the F value again that I'm looking for is this one. So I'm gonna copy it. All right. There's another way to do it, the approximation. If you right click and you go to format cell here, you're gonna come up a menu, go into numbers and make sure it's 2 because the F test is 2. And for the p-value you can do the same thing, or you can use these small icons over here. So if you want to increase the number of digits or decrease number of digits, so if you decrease it to 3 it should be fine. So the p-value we will need it as well, right? So that's the 2 values we need. So 0.21, let's copy it, go back, so place it in and check. And the next question, they are asking for the p-value. So this is the p-value. Copy and paste and check. All right, we're done. Now we have the same statement that we discussed it earlier. So we have these two statements, all depend from the p-value. So here again, this is my p-value 0.887 and this is the alpha 0.050 if they are 3 digits, right? Obviously the p-value is greater, so we are not rejecting A0. So do not reject goes always with insufficient. And check, and we're done with this. All right, so here I did not discuss why we are using the Levene test of homogeneity, and the reason is actually the first test. All right, so here there is a small explanation in your book, so let's go over it together. So here is saying, so once does not reject A0, so that's the case when you use a Levene test, right? There is insufficient evidence, we talk about this already. There is of a significant difference among the 4 variants, right? So why we need to talk about the variance, all right? The purpose for this, because one-way ANOVA for F-test assumption, there is a condition here, the randomness, normality, and there is a homogeneity of variance. So homogeneity of variance, it means all the variances should be the same, all right? And the homogeneity of variance, that the Levene test, all right? That the one that we just did, all right? So when do you do it? So you do it only whenever you run the F-test, and then you do not reject A0. So if you did not reject A0, this it means there is no difference between the means. Mean 1 equals to the mean 2 equals to all the means, right? So now this statement is not quite correct yet unless you verify that there is a homogeneity, all right? That's why we do another test to figure out that the initial condition, they were existing, all right? So if we get the homogeneity, again, homogeneity, you're gonna do another F-test and you need to not reject, all right? The same scenario that we did here in question C. So that's the test. Once you do not reject it again for the Levene test, then this statement will become correct, All right, this statement will be a correct statement. It means there is no difference anyway. All right, so for this reason we're gonna go with the last choice. There is insufficient evidence of a difference in the mean thickness of the corn flakes because the null hypothesis was not rejected. All right, let's check it. All right, that's the correct one.